Hello friends, welcome to my channel Code Destination. So we are continuing this challenge one code one day, and we are taking the topic binary search algorithm. So in previous day I discussed already binary search algorithm in detail, and I also did discuss one problem in which we generally found like lower bound and upper bound. So today we will also see the one different type of question which uses the binary search, and how we can think binary search algorithm in a different type of questions, and how we can apply. So for today we are taking this question from LeetCode, which is question number 33, uh, which is named search in rotated sorted array. So basically in this question we have given the sorted array like this. Basically this sorted array is rotated, like here we can see like the sorted array is 0 1 2 and 4 5 6 7. So it rotated four times. That's why this zero should be at the zero index, but it is at the fourth index. So basically it is rotated, and this array is also sorted. So how we can solve this problem using binary search, and so we will discuss each and everything, like why we should think binary search in this type of question, and how we can build the logic. So we will think about that as well. So let me share my whiteboard. Yeah, so we have given this example, and we want to find the target 0. So as usual, like in previous question, I also like draw the number lines for solving the any binary search related question. So with this question we can also and like we can also understand one thing, that binary search is not restricted, like we can apply only binary search on the like sorted array, or like ascending order sorted or descending order sorted array. It is not compulsory. Actually the truest, like the right assess like right statement to say where we can apply binary search. Basically all the data structure which follow like some pattern, or like some pattern which like some pattern of sorted behavior. Like if any like data structure, like in this case is this array is having some sorting behavior like in by default, so we can think here the binary search. So yeah, please note that thing as well. So for this question we have given this array and we have given this target. So first we will draw on the number line. So suppose my number line is this one, and suppose my this 4 5 6 started for here, then it is 5 6 and 7. So it is going till here, and after that it is starting from 0. Here it is break, like that increasing point is breaking here. Then start from 4 here. Now we are starting from 0. Suppose 0 is here, and we in starting we start this from this baseline. So I just draw this baseline here, and like after that we start from 0. So 0 till 0 1 2. So suppose till here, and for making clear I just expand it till here. Okay, so we can draw like that on the number line. So once we draw we can see like some pattern, and we can do some observation. So the first observation which we can do using this graph, we can see there are two half, basically this first half and the second half, and both like both part, basically two part, and both part is sorted. So there are two part which is sorted in our given array. And the second observation what we can do, we can do like our target either lie in the first part or second part. So target can be lie in the first part or the in the second part. Suppose I write this first and this second. So either it can lie in the first part or second part. Okay, the third point. So our just like we can directly if we know like this two part is sorted, so we can directly apply the binary search in different part. But for that we have to justify from where it is like not like basically from where it is just break the sorting behavior. So for this case, like from here it is breaking that sorted behavior. Okay, like this is a peak point, like it is start from here, it end here. Okay, then after that it start from some point and it like end from some point. But anyhow, if I like get this point like from where it is our array is breaking, so that we can just say that suppose this point is m, so we can say that from 0 to m this array is sorted. This is my first part, and the second part will be m plus 1 to n minus 1, suppose n is the size of array. So this will be the second part, this is the first part, this is the second part. So basically we need to find this point from where it is like breaking the sorted behavior. So what we will generally do, first we will try to find this point, and after that we will like once we got the point, we can apply the separate binary search in this part and in this part, because both the array is sorted, and we know that we can apply the binary search in the sorted array easily. So our task is to find this point, like this m point from where the sorting behavior is breaking. So how we can think about how we can find, so for that we will make a logic. So what we are doing, first we will find point, basically this is the breaking point. We will find the breaking point, which is suppose I assume any m point. Okay, then second, apply binary search in part 1, like first part, then apply binary search on the second part. And in this way we can find our target element, and during apply we will pass the target, like we will basically search our target in both part, because target either like present in the first part or in the second part, otherwise it will not present. If it is not present in both part, then definitely it is not present in the array. So in this way basically we can solve this question. So let me explain how we can find the middle part here. So like in previous binary search, as I already discussed that like we have given some target variable, but here in this case target is not given. So I assume, like suppose I am going to find the middle part, so I will assume that like is there any behavior of the target, like suppose I'm going to find this breaking point. So for this point, is there any behavior which is differ from every element? So we can see one thing, like from every point, suppose I assume any point either on this side, like at this line, or at this line. For every point, every previous element is less than like every previous element is less than the current element, correct. But for this case this element is greater than the like this element is greater than the uh, like the element which is present after. Basically for first part, all the element, suppose I assume this all ai, all the element at first part is less than I plus 1, correct, for first part. For second part, all the element is also less than the element which is after that. Okay, so in this, like this two property hold in both arrays. But for middle point, like for the breaking point, we can see but for breakpoint, what we can see, the element of breakpoint is greater than element which is present after that, m plus 1. Okay, so this with this property we can say that we got our target, because here the target is not given. Suppose I am going to find the point like this breaking point using binary search. So in that we have to define our target behavior. So this is our target. Basically, when this condition hold for with any element, so we can say that this is our target element. Correct. So we can define our target like variable, what is the behavior of target element. So this is the our this is the behavior which by the help of which we can say that this is the target element. And the second point, in binary search in general, what we did, like we generally check the element like with the target, and that element is less than the target. It means all the element before that we can ignore. So for this case, how we can ignore? Suppose I assume in general what we do in binary search, we just take two boundary like pointer I and j, and with m like we find the middle point. Suppose in this case, what is the different case for middle point? Suppose it can be here, either it can be at this line, at this part, or it can be in this part. So for both we can see, like if it is present at this first part, so we have to move right side. Okay, and if it is present at this part, so we have to move left side. So this is sure, like the direction is sure where I have to move. Like if it is present like here, like my m pointer middle pointer I am finding it is present here, so we know our target is here, so I have to move thus the right side. And if it is present here, though in that case I have to move left side. But how we can justify that whether it is present at this like part, or at this part? So for justify that we have to find something. So we can say one thing, all the things is like all the first part is present above this line our baseline. Okay, so this with this baseline all the things the first part is present above that, and suppose this is my baseline. So basically all the for the first part all the element is greater than our base line, basically base element, which is 4 here in this case. And for second, all the element is less than our baseline, because in diagram we can also see like this second part is just below that, and first part is just after that. So with this condition we can justify that whether we are present in the first part or in the second part, and accordingly we can move our like pointer. So in generally in binary search we need only two things. First thing, the target. So I can say with this condition my target I got. And the second case, how we can move our pointer left side or right side, like how we can ignore the sum of the part in the binary search. So with this condition we can justify if it is in the first part, so we have to move right side, right direction. And if it is present in this part, so in that case I have to move left direction. So if I will implement the code, then you can connect this logic. But for now I hope you are like clear with the logic. So let me implement that code so that you can, and also that I will connect that code with the logic so that you can just understood. So first I have to find the peak element. So I will find peak element here. Okay, so nums, and there are no target defined. Okay, so in general we are finding using the binary search, so I will define my boundary 0, and my jth will be last index. Okay, and I will make loop I less than equal to j. Okay, and I will find the middle, like we did binary search, I plus j minus I by 2. And yeah, if you didn't watch my previous video, please watch, because that will help to write the binary search with the more clarity. And here we generally what did, we just compare the target here in the like normal binary search. But For target we are defining the condition. So for target, now what we will do here, like for defining the target, I define this behavior, correct, this behavior. So this behavior I will implement. If this behavior hold, so it means we got a target, because our target is only element which is greater than the element which is present after that. Okay, so that behavior hold with the peak element only, like from that breakpoint, and our that breakpoint is our interest, and we want to find the breakpoint. So if any case, if nums of m is greater than nums of m plus 1, so in that case we got our peak element, or I can say our target. So I will return that index directly. And otherwise, in general, what we did, if my nums of m is less than nums of which element, as I defined already, like if I present in the first part, then I have to move right side. So for moving the right side, suppose I am present at this part, I am here. So for that, this condition hold, because all the element is greater than this base element. Base element nothing but this base element is a of 0, because this first element is base element. Okay, so if this condition holds, it means we are in the first part. So I will move right side. So how will move right side in the binary search? I will just shift my I. Suppose my m pointer is here, so I will shift my I to the after that m pointer. So my I will be m plus 1. Okay, so I will shift in that case. If my m is greater than my 0th boundary element, so my j will shift. Okay, sorry, for that actually greater than, because in the first part it is greater. So in that case my boundary will shift I equal to m plus 1, and otherwise the right boundary will shift. So in that case I will do m minus 1. So in this way that will move, and we can find the peak element. But there are one case we have to like concern, like here we are comparing this m with the m plus 1, and we are making this j and like num length plus minus 1. So if it will add, then index will be out of bound. So I have to one check here as well, so that index will not go out of bound. If my m is less than nums dot length minus 1, in that case I have to check this condition. Okay, otherwise it will like throw the index out of bound exception. So in this way we can find the peak element. Let me find peak element index. So what I have to do here, I will find the peak element index. So find peak. Okay, find peak nums. So let me return for now here that peak element directly, and we can see whether it is giving the correct answer or not, like for peak element not. And yeah, here I have to return minus 1 if we didn't got any peak element. Yeah, so let me run it. Yeah, so for this case we can see like 4 5 6 7. So peak element index is 0 1 2 3. So our output is 3, so it means it is correct. And for case 2 it is same. For 1 it is giving minus 1, because there are no peak element. For this it is giving the peak element 0, because like from 5 it is peak element, correct. So for this it is giving 0 1 2 3, it should give, it is correct. So we are just, we can say that we are getting the right peak element index. Okay, so we got our peak element now, peak element index. So our first task is complete, like find the peak element index. So this find the breaking point. So this first task is complete. Then after that we will apply binary search in the first part, because now we can say that from starting to this peak element, this part is sorted, so I can apply binary search directly, and this part is also sorted, so I can apply binary search in that part. So for binary search I am not writing the code, because in previous I already write this binary search. It is very simple. So if you haven't watched that video, please watch that. So that will be clear. So I can just use that binary search code here. So in that case I have to just pass my boundaries dynamic manner. So what I have to do, yeah, so here left low I will pass high, and for low and high, okay, I have to just say that, okay, so in our function I will pass low and high indexes, because in that case we have to apply two like binary search in two separate parts. So that's why I pause my boundaries here. Okay, and there are also one case which we have to check. Basically, like suppose this array is size of only one size. So in that case uh, I can directly say, like, for this is a corner case, suppose my given array is size 1, so we can directly check that element, like if my nums 0 is equal to target, it means the target is present, and we can return directly here that we got the target and this is the index. And if not present, so in that case I have to return -1. So I just write for this case especially here, and after that I found the peak element if index like num size is greater than 1. And in that case what we can do, um, if I will check if my peak element is -1, it means we didn't got any peak element in that element in that array. So like in which case it can happen, basically we can say here, like for finding the peak element, what is the behavior? A of m value is greater than m plus 1 value. So suppose this is given the suppose we have given array in the sorted manner. So in this way we have given the array. So in that case this condition never hold, correct? Because for this last we can't check because our array is end here, so we can't check with the m plus 1. Okay, so in this case it will give -1. Basically when the array is sorted in the ascending order, in that case it will return the -1. So like with -1 we can like say that it is sorted in ascending order, so we can directly like apply binary search in the whole array. Okay, but with suppose it is given in the descending sorted order, suppose it is given like that. So in that case for this element is greater than m plus 1 element, so in that case it will give this peak element value. Okay, so that for that case it will return the peak element index. But if it is sorting the ascending order, so in that case it will return -1. So suppose it is returning the -1, so in that case what we can do, we can directly apply binary search in the whole array. Okay, so in the whole array we will apply that. So we'll apply binary search in the whole array. So I will pass nums here 0 and last index the length -1, and we will return that one, because with -1 we can say that it is ascending order sorted. Okay, so if it is not sorted in ascending order, so I will search in the first half. So I will write in the R1, or I can say first part, and I will just apply binary search in the first part. So I will apply binary search in the first part. So first part starts from where? From 0 to peak element. So from 0 to peak element index it will start, and we will apply binary search. And if this fe, suppose fe equal to -1, it means we didn't got in the first part. Okay, so in that case I have to search in the second part. So I will search in the second part. So second part, from where it start, peak element +1 to nums length, like from last index. So this is the second part, and after that I will check if I will get not -1. Basically it didn't, because if it didn't find, then it will like store like -1 in the fp and it will directly return. So I can directly return here, no need to check. Yeah, So what we are doing, like first we just check a special condition, like if size is 1, so in my target, like suppose target element is the first element and the length is also 1, so just return that 0th element, otherwise -1, it is not present. And I just find the peak element. So if I got the peak element, so just all the element before that is sorted and all the element after that is sorted. So I just check if the peak element is not -1, because if it is -1, it means that this array is sorted in the ascending order. As I explained here, in this case it is sorted in the ascending order. So in that case there are no peak element we found. So in that case we will apply the binary search whole array and we will return that index. And otherwise if we got any peak element, so we will apply the left part. And if we didn't find the in the left part, in that case this fp will be -1, then we will apply in the right part. And once we got the right part answer, then I will return fp directly. So let me run it and see whether our logic is working or not. Yeah, so it is giving some error. What error it is giving? B search. Okay, nums target. Oh, okay, I have to pass target because in the array what we are going to search, we are going to search our target element, so we have to pass that thing, target. Okay, I think now it should work. And target, yeah. So let me run it again. Yeah, so all the test case pass. Let me submit it again. I think that should work because logically it is correct. Yeah, so it is submitted. It is taking 0 millisecond and it is beats 100% of users of Java. So as like we discussed in the logic, we same manner we implemented the code. Like first we find the peak element, and for the peak element I implement the logic according to the logic what we explain here. For finding the target their own behavior, then mm, like whether we are present the left hub or right hub, accordingly we have to switch. If you are present the left hub, we have to switch right side, and if you have the right hub, then you have to switch left side. So accordingly we are just shifting, and we can see in the code we can implement directly. And this is the binary search. We are applying binary search in two part. So in this way we can solve this question easily. I hope you understood this concept, and if you understood, please like this video. And for now we can also explain the time complexity, but as we can see, like basically we are applying the binary search 3 times in the find, peak, in binary, in b search, in b search. So in the three method we are applying the binary search, so it is 3 into log n solution, and in the last it is log n solution because it is 3 into log n operation. And so it is 3 at last, we can ignore the 3, so we go of log n operation it is doing. So I hope you understood this solution and intuition behind this and how I build the logic. So if you like, please subscribe my channel so that in future I uploaded any video you can just see and understand the logic. And maybe we will like in a static class we discuss different variant, and today so we discuss the different variant of binary search. And in upcoming class I will take this question again, like we will think how we can solve this question using only one binary search. That is very interesting. So maybe tomorrow session we will like discuss about that, and we'll continue our challenge one code in one day. So yeah, thank you for watching my video.